Hi, in this video we're going to do some practice problems with work and heat that we learned from the previous video. So first it says two solutions at 25 degrees were mixed in a beaker and precipitate formed and temperature of the new solution was dropped to 19 degrees Celsius. Did the amount of energy contained in the system increase, decrease, or stay the same? Well, as we learned, energy is conservable. So did the amount of energy contained in the system increase, decrease, or remain the same? So what is our system and what is our surroundings? So over here, precipitate is the system and the solution is the surrounding. Now we know that the surrounding decrease in temperature. So if the surrounding decrease, what happens to the precipitate? Well, it will increase because it absorbed energy from its surrounding. Now, was the chemical reaction that took place endothermic or exothermic? The answer is endothermic because the surrounding decreased energy because the energy was absorbed by the system. So it's endothermic because the system is absorbing energy. Did the amount of energy contained in the surroundings increase, decrease, or remain the same? Well, this one is just the opposite of A. It is decrease because the temperature of the solution dropped. Next, the student puts the beaker with 150 milliliters distilled with water on a hot plate. As the temperature of the water increases from 22 to 85, did the amount of energy contained in the 100 increase, decrease, or remain the same? So for this one, let's first identify the system and the surrounding. So we're heating up the water. So the water is the system and the surrounding is the beaker. So did the amount of energy contained by the 150 milliliters of water increase, decrease, or stay the same? And the answer will be increase. Because as temperature increases, so does energy. The water's temperature is increasing, so energy increases as well. So is this endothermic or exothermic? The water being heated up will be exothermic because it released heat, causing the beaker to feel hotter. Next, a gas contracts from 4.26 liters to 1.89 liter in a cylinder with a constant external pressure of 1.10. Now we're using work and heat. Calculate the work associated with this contraction in joules. To calculate work, let's do W is equal to negative P delta V, which is equal to negative 1.10 times delta V change in volume, which is 1.89 minus 4.26. Negative 1.10 times 1.89 minus 4.26. And the answer is 2.607. Now, what are the units? This is atmospheres and this is liquids. So our unit is atmosphere times liquid, but we want it in joules. So to do that, we need to do another step, and that will be to 2.607 atmospheres times liquid times liters. You need to know this. For every 1 atmosphere times liter, there is 101.3 joules. So let's see, 2.607 times 101.3 will give us 264 joules. So our answer is 264, the work. The work associated in this is 264 joules. Now, was the reaction endothermic or exothermic? Well, it is endothermic because the work is positive. Positive work means it's endothermic. Endothermic. Because work is positive. Number 10, 1,354 joules of heat are absorbed by a balloon from the surroundings, which causes the gas inside the balloon to expand from this to this under constant external pressure of 1.07. Alright, what is the change in internal energy? Alright, so in order to calculate the change in internal energy, we first need to calculate for work. And work is going to be equal to negative pressure 1.07 times delta V, which is 3.98 minus 2.31. Alright, now we grab our calculator and do negative 1.07 times 3.98 minus 2.31, and we get negative 1.787. 1.787. And then this is atmospheres per liter, so we also got to multiply it by 101.3 to get to joules. And we get negative 181 joules. Now calculate the external energy. Delta E is equal to Q plus W. So what is our Q? Let's see. It says 1,354 joules of heat is absorbed. So that means it's a positive Q of 1,354. And then we add our work, which is negative 181. So add negative 181. Because both of these are joules. Let's see. 1354 minus 181 joules. We'll get an answer of 1173. 1173 joules. Now, was the expansion of the balloon exothermic or endothermic? The answer is endothermic. Endothermic. Because the balloon absorbed energy. Now, was energy conserved during the process? Justify answer in terms of magnitudes of the energy changes that occurred. So for this one, heat flowed overall from the surroundings into the system. As we can see from our positive value. Alright. Let's see, positive value. So heat flowed into the system. And the magnitude of the heat was greater. No, the magnitude of the heat into the system was greater. The magnitude of the heat into the surroundings, aka out of the system. So for this one, gas expands and does work on the surroundings equal to 325 joules. At the same time, it absorbs 127 joules of heat from the surroundings. Calculate the change of energy. So change of energy is equal to work plus Q. And let's see, work, it says, does work on the surroundings, which is negative 325 because it is done on the surroundings. And this is for work plus our Q. It absorbs 127, and since it absorbs heat, it's going to be a positive 127. So what is negative 325 plus 127? That will be negative 198 joules. Next, the work of the compressed gas is 74 joules, and 26 joules is lost. Alright, so again, is equal to work plus Q. What is work? Work is 74. The work done to compress is 74, so it's going to be 74 is done on the system, 74 joules, and then as a result 26 joules of heat is lost to the surroundings, so it'd be a negative 26 Q. So what is 76 minus 26? Minus 74 minus 26 is going to be 48 joules, equals 48 joules. Alright, calculate the work done on 50 grams of tin is dissolved. Now first, to calculate the work, let's do this step by step. Let's first convert the 50 grams into moles. Alright, so 1 mole of tin SN is going to be, let's see, 118.71 grams, and then over here it's 1 mole of H2 for 1 mole of SN. Why do we use S2? Because we need to use the gas in order to find V. I'll show you in a bit. So first, let's do this. Right, let's find how many moles. 50 divided by 118.71 will give you 0.421 moles. Now, we're trying to find work. Work is equal to negative P delta V. negative P delta V. We have the pressure at 1.0. So now basically delta V, the changing volume is the negative changing volume is our work. So how do we find the changing volume? Well, V is also equal to nRT divided by P. PV equal nRT. You just flip it. You just divide both sides by P to get V. Okay, now you have this. We have volume is equal to number of moles. We have 1 mole of H2. So it's going to be, we just solved 0.421 moles. 0.421 moles. And then we multiply that by the gas constant, which I remember is 0.0821. And then we multiply it by the temperature, which is 25 degrees Celsius, and that is 298 degrees Kelvin. Finally, we divide it by the pressure, which is 1, and we're going to get, let's see, 0.421 times 0.0821 times 298, which is going to be 10.3. 10.3 liters. Now, work is equal to negative 1.0 times 10.3. So, work is equal to negative 10.3. And it's going to be atmospheres times liters. So, when converted to joules, 101.3 joules, 1 atmosphere times liter. So, negative 10.3 times 101.3 is going to be negative 1043. So, 1040 equal to 1040 joules. Now, the key thing to remember is to always multiply it by 101.3 joules to convert it back into joules. Number 14, calculate the work done in joules again when 1.0 molar of water, 1 moles of water is frozen at 0 degrees, and the volumes of 1 mole of water and ice is 0.01801, and that is work being done on the system or on the surroundings. So let's see, work equals negative P delta V, which is equal to, 1 atmosphere, negative 1 atmosphere, times, this is the change in volume, so 0.0196 minus 0.01801, which is, well, let me make sure. Alright, the volumes of 1 mole of water and ice is the work being done on the system. Alright, yep, this is the change in volume. So now, which is the unit for this is liters. So now this is going to be equal to 0.0196 minus 0.01801, which is equal to negative 0.00159 because of the negative 1. And then this is atmosphere times liters, and the formula is 1 atmosphere times liter equals 101.3 joules. Okay, now negative 0.00159 times 101.3 is going to be equal to negative 0.161 joules. Okay, now the work being done on the system or on the surroundings. Now, because our work is a negative number, that means the work is being done on the surroundings. Alright, positive work means the work is done into the system, and the negative means it's done on the surroundings. And that's it for today's practice problems. In the next video, we're going to be talking about bond energies. Thank you for watching.